one pixel has a lot of secrets. Hi, I'm Egor Prikaziuk, and I'm going to tell you about scales and remote sensing, topic of Senseco Working Group 1. Let's go. Well, scales, as the levels of biological organization, start from the biosphere, the biggest, through ecosystem and communities, populations and organisms. They go all the way to micro and nanoscales through organs, tissues, cells, organelles, and atoms. Large scales can be easily imagined in remote sensing. The drone sees some with high resolution, plane with a little bit coarser resolution, satellite in 1 pixel. As a result, the resolution degrades between different satellites, different models, and what you can see on Earth, different leaves, cannot really see them on the big scale, and it's more often not even necessary. Small scales is a different story. Unless you're a biologist, as I am, it's very hard to imagine what's going on there. Of course, we know photosynthesis and the exchange of carbon, oxygen, water with energy of sunlight, but what is actually happening inside the leaf is this light interacts with the leaf and it's reflected, it's absorbed, it's transmitted, it's distributed as heat. And the reflected light is what remote sensing sees. For example, with spectrometers like that. As we know, there is a specific pattern of reflectance of vegetation. This I will tell you about later in the working group 3. But besides reflectance, there's also tiny bump on the reflectance curve is fluorescence. I'll also describe it in the next videos. But for now, we are interested in the energy that is actually being absorbed. And this is analyzed by such a tool as a pump fluorimeter. And there's also fluorescence, but a different type of fluorescence. It's an active fluorescence. So the internal life of the leaf is very dynamic and depends a lot on the leaf structure. And if we're interested in the process itself, in photosynthesis, it's much nicer just to count the carbon dioxide molecules that went in or oxygen molecules and water molecules that went out. This is also done with, uh, with such tools as a gas exchange analyzer. And for example, light response curves are being built with varying intensity of light or varying intensity concentration of CO2. Where is the synergy? How to connect large Earth observations to a tiny leaf observations? Well, here it is in remote sensing. We go from leaf all the way to the biosphere. And what can be upscaled? Light in the first place, and it's called radiative transfer. And processes. Light is upscaled within models, different kinds of models, and there is a serious competition called Radiative Transfer Model Intercomparison, or RAMI, that showed that the most accurate representation is not actually the best one. All the models are available in one GU developed in Senseco as ArtMod toolbox. Such models as Scope, Flight, and Dart can be seen there, and there is a tutorial on Senseco webpage. But then processes, photosynthesis and evaporation, they are being upscaled in a different manner, a single leaf, two leaf, multi-layer leaf. And scope model upscales not only light, but also processes. There's a tutorial from the model creator, Christian van der Tol, and also a talk from me, how to model water and carbon fluxes. So upscaling is a topic of Sensec Working Group 1, led by Mapi, Javier, and Shari. They develop ArtMod toolbox. They provide data sets of multi-scale Earth observations, and they create measurements protocols. See you in the next videos.